So for topic 4, we're going to focus on reducing fractions. That's what the last few videos have really been leading up to. So definitions, and then we'll kind of discuss two methods, then we'll practice the two methods. So definitions, the equivalent form, so we're looking for an equivalent form of a fraction where the numerator and denominator have no common factors is called simplest form or lowest form, okay? So then it says the process of writing a fraction in lowest terms is called simplifying or reducing the fractions. So you could be asked to reduce a fraction, simplify a fraction, write a fraction in lowest terms, write a fraction in simplest form. All of those things mean the same thing, and it means get an equivalent form of the fraction where the numerator and denominator don't have any common factors. Okay. Now, one definition that we need for one of the two methods is called the greatest common factor. So we need the definition for the greatest common factor, or we generally just simplify it by saying the GCF. So the GCF, or greatest common factor, of a pair of numbers is the largest factor both numbers have in common. Okay, so that's a generally pretty easy concept. So if you have two numbers, five numbers, just any kind of group of numbers, the greatest common factor is quite literally the largest factor those numbers have in common. Okay, now as for the two methods for simplifying fractions, there are two kind of official methods for simplifying fractions. And what I find is generally students kind of merge the two. They do kind of like a combination of the two, and that is absolutely fine. Just make sure you know the two methods, and at the end of the day, make sure you know how to simplify a fraction. Okay, so the first method is the GCF method. Okay, so we find the GCF, which remember, that's the greatest common factor for the numerator and the denominator, and then divide the numerator and denominator by the GCF, and then just double check and make sure your final fraction doesn't have any other factors that could be divided out. Make sure you really truly got the greatest common factor. The second method is the prime factorizations method. So what you do here is you find the prime factorization of the numerator and the denominator, and then you cancel any factors that match top to bottom, okay? So let's look at example 7. All right, so in example 7, it says simplify each fraction using the GCF method. Now, there are formal methods for finding a GCF, and I find that students get so lost in these methods that they just get frustrated. So I'm just going to kind of walk you through how to find the GCF. So what I do is I look at the smaller of the two numbers. In this case, looking at example 7, part A, 24 over 36. 24 is smaller. This is a proper fraction, so the numerator should be smaller than the denominator. So I want to look at factors of 24. So I could write 24 times 1. I could write 12 times 2, 3 times 8, 4 times 6. Those are all the different factor pairs of 24. So I want to start largest to smallest and see which of these factors is common with 36. So does 24 divide into 36 evenly? No, it does not. You would get a fraction or a decimal if you divided 24 by 36. So go to the next largest. So we're going to look at 12 now. So does 12 go into 36? Yes. 36 divided by 12 is 3. 24 divided by 12 is 2. So that's going to be the GCF. So this right here is the GCF. Now, that doesn't mean these other numbers are not factors of 36. 2 is a factor of 36. 3 is a factor of 36. 4 is a factor of 36. 6 is a factor of 36. But we're looking for the greatest common factor, which is 12. So then what we do is we just divide 24 by 12, and then we divide 36 by 12. And let's see, 24 divided by 12 is 2. 36 divided by 12 is 3. So we've decided that the reduced version of 24 over 36 is 2/3. And if you want to check this, remember, when you're simplifying fractions, you're looking for an equivalent form of that fraction where the numerator and denominator have no common factors. So you can check to see if these two fractions are equivalent. So I would take the first numerator, which is 24, multiply it by the second denominator of 3. I would take the first denominator of 36, multiply it by the second numerator of 2. And let's see, we get 24 times 3 is 72. If you don't believe me, use your calculator. 36 times 2 is 72. So we can say without a shadow of a doubt that 2/3 really does equal 24 over 36, and 2 and 3 have no other common factors. All right, so let's look at part B. So the numerator is 28, the denominator is 42. So we're going to look at the smaller of the two numbers, which is 28. So I want to look at factor pairs. So I get 28 times 1, 14 times 2, 3 doesn't go in, 4 definitely goes in, 7 times 4, 5 and 6 are not 5. So those are the factor pairs of 28. So I want to start biggest to smallest, and I want to see which of these are also factors of 42. Well, 28 is not a factor of 42. If I took 42 and divided by 28, I'd get a decimal, okay? So we know 28 doesn't work. Let's go to the next largest factor, which is 14. Well, 14 definitely goes into 28. It goes in twice, but it just so happens that 42 divided by 14 is 3. So 14 is a factor of 42, and this means that 14 is the GCF. Now, 2, 7, and 4, well, 2 and 7 are also factors of 42. They're just not the greatest factor of 42, or the greatest common factor between 28 and 42. So just like before, we're going to divide the numerator and denominator by the GCF. This was poor planning on my part. Not all fractions reduce to be 2/3. It just so happens this one does as well. So 28 divided by 14 is 2. 42 divided by 14 is 3. So we get 2/3. And again, you do not always have to check, but if you want to check, if you ever reduce and you're like, that just feels kind of wacky, check, see if the two fractions are equal. So I would take 28 times 3 and 42 times 2. So let's see, 42 times 2 is 84. Let's double check. 28 times 3, also 84. So we're good to go. We can say that 2/3 truly is equivalent to 28 over 42, and 2 and 3 have no common factors. So 2/3 is the reduced or the simplest form of 28 over 42. Okay. Now for the next method, we're going to look at the prime factorization method. And again, a lot of times students kind of merge these two methods. As long as you get your fraction reduced, that's fine. But for the prime factorization method, we want to find the prime factorization of both the numerator and the denominator. So let's start with the numerator. Now, 90 can be broken down into many different factors, but I like to divide it by two factors that are closer to the same size. It's just quicker. You could certainly do 2 and 45. You could do 3 and 30. There's all different ways that you could break down 90, but for me, I want to do 9 and 10. I know that anytime a number ends in 0, it's divisible by 10, and that's an easy place to start. Now, 9 and 10 are not prime, so I want to break them down further. 9 can be written as 3 times 3. 10 can be written as 2 times 5. So I'm going to come over here, and I'm going to rewrite my numerator of 90 as 2 times 3 times 3 times 5. Okay? And then I'm going to repeat that process for 120. So again, I have a number that ends in 0. I like to just go ahead and divide by 10. So I get 12 times 10. Any number that ends in 0 is divisible by 10. 12 and 10 are not prime. So 12, you could write this as 2 times 6 or 3 times 4. Legitimately does not matter which. So I'm going to do 4 times 3. 10 I can write as 2 times 5. Well, 4 is not prime. 4 could be written as 2 times 2. And then 3 is prime, 2 is prime, and 5 is prime. So I'm going to rewrite 2 times 2 times 3 times 2 times 5. I'm going to write those factors in the denominator, but I'm just going to put them in order smallest to largest. And you don't really have to do that. I just like to. So I get 2 times 2 times 2 times 3 times 5. So now I want to look to see, does anything cancel top to bottom? Okay, so I notice this 2 in the numerator divides this 2 in the denominator. 2 divided by 2, just leave behind a 1. I notice this 3 in the denominator. What in the world? Sorry, I just got an Amber Alert on my phone. It kind of scared me. Okay, so where were we at? We were taking these two prime factorizations. We had the prime factorization for 90 in the numerator, prime factorization for 120 in the denominator. We already saw a 2 in the numerator and denominator that divided out to just be 1. Now we're looking at a 3. The 3 in the denominator is going to divide out one of the 3's in the numerator, leaving behind a 1. And then the 5 in the denominator is going to divide out the 5 in the numerator, leaving behind a 1. So when we simplify here, we want to look for all of the non-1 factors that are left over. So this becomes 3 over 2 times 2, or 3/4. And again, you do not always have to check, but know that you always can check. So if we want to check this, we want to know, does 3/4 really equal 90 over 120? So I'm going to take 90 times 4 and see if that equals 120 times 3. Well, 90 times 4 is 360. 120 times 3 is 360. So we can say without a shadow of a doubt, 3/4 really does equal 90 over 120, and 3 and 4 have no common factors, so that is the fully reduced version of 90 over 120. And then let's just do this one more time really quick for example 8, part B. So I'm going to start with 28. 28 could be written as 7 times 4. 7 is prime, so I just bring it down. 4 is not, so I rewrite 4 as 2 times 2. So my numerator is now going to be 2 times 2 times 7. And then I'm going to find the prime factorization for 60. 60 could be written as 6 times 10. 6 is not prime, so I would write it as 2 times 3. 10 is not prime, I would write it as 2 times 5. So over here as the denominator, I'm going to rewrite it as 2 times 2 times 3 times 5. All right, and then we want to see what'll cancel. So 2 divided by 2 right here, those cancel, they divide out to just be 1. 2 divided by 2, again, they divide out to be 1. And then it looks like the numerator of 7 has nothing to simplify out with. The denominator is only a 3 and a 5, so there are no other factors that could cancel. So we get 7/15. And again, you can always check. So I could say, okay, does 28 times 15 equal 60 times 7? Well, let's take our calculator and see 28 times 15 is 420. 60 times 7 is going to be 420. So we have verified that 7/15 does equal 28/60. It's just reduced. 7 and 15 have no common factors, so 7/15 is lowest terms. Make sure you understand how to divide. Even if you divide out and kind of like merge these two methods where you find a common factor and divide it out and then look to see is there another common factor and divide it out and just repeat that process, that is fine. Just make sure you know how to reduce fractions.